Hello, I welcome you all to your own channel. I'm scalar. Now, in this video, we will solve the problem related to the vector calculation, right? So the problem on the screen that show that the vector x square minus yz plus y square minus zx plus z square minus xy is irrotational and scalar potential, right? So as whatever the function is given, that vector function is given, that whether it is irrotational or not, how to check. So first of all, we need to find out the given function curl, right? If the curl of a given vector is equal to 0, it means that that particular vector is an irrotational, right? Then if it is irrotational, it means what? That you can say vector f is equal to that gradient of phi. So first of all, we need to find out the curl of a given vector, and then we'll check whether the curl is 0 or not. So here we go, that solution. That given vector is this, so we can say let f is equal to, that is vector f is equal to x square minus yz of I plus y square minus zx of j plus z square minus xy of k, right? Okay. Then first of all, we will find out the curl, right? Then we can see that here we go, the curl f is equal to, how we find the curl, that is determinant of I, j and k, right? So the coefficient of I is what? That first we will write down the dou by dou x, j means dou by dou y, and dou by dou z. Then we will write down the coefficient of I, j and k. I coefficient is x square minus yz, j coefficient is y square minus xz, right? And k coefficient is z square minus xy, right? Okay. So then you can find the determinant, that I you have to take this row and this column will be height, and then you can see. So I'll show you that this is how it will be. That means you can say I, right, into dou by dou y of what? Z square minus xy cross multiply minus dou by dou z, this y square minus xz, right? Okay. Then similarly we have a plus minus alternate sign we have to take. So this is the continuation, minus j into this, and this will be eliminated. So that is what? Dou by dou x, this will multiply with this, that one, that is z square minus xy, and minus dou by dou z, and this one, that is x square minus yz, right? Continuation plus k. So k means, I'll show you this, and this will be height, so this into this, right? So as you know that how to find the determinant, right? Dou by dou x of y square minus xz minus dou by dou y of x square minus yz, right? Now, so I'll show you that differentiate, partially differentiate with respect to y, it is minus x, right? Z means minus x, so minus minus plus x, this will be 0. Okay. Partially differentiate with respect to x, so its differentiation is minus y, and its differentiation is minus y. Minus minus plus minus y will be get cancelled, that is 0. So differentiate with respect to x, that is minus z, and this is minus z, so minus minus plus z means that curl of f is equal to 0, right? So we got. Now we can say next we can say that since the curl of vector f is equal to 0, therefore right, f vector f is irrotational, right? Then there exist phi such that you can say, wait, such that vector f is equal to gradient of phi. All right. Okay, so gradient of phi means what? I of dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. All right. Okay, so here we go again, that for irrotational, first of all you have to show whether the given vector is a what we call, that is, its curl is 0 or not, right? So that we already see. Just hold on. All right. So then you can say, that is, again I'm writing, that is f, just yes, f is equal to gradient of phi, which means you can say dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k, right? All right. So this is what you have. If you already know x square minus yz I plus y square minus zx j, right? So that we can say, what is that? This is directly you can say f is equal to what? F is equal to x square minus yz of I, which is given, plus y square minus xz of j plus z square minus xy of k, right? So we have to take the coefficient of I, j and k in this, right? So first we can say dou phi by dou x is equal to what? Is equal to x square minus yz, right? So you can write down like that also, that is d phi by dx is equal to x square minus yz. To simplify this, what I'll do, that you can integrate. So d phi is equal to x square minus yz into dx, right? So integrating this term, so differentiation will be eliminated. So this is what? Phi integration of x square is x cube by 3, right? X cube by 3 integration of this is yz dx, right? So minus x y z, right? And there is obviously plus f1 of function of what? That is y and z. Let's say this is the equation 1. Similarly, you can go for the dou phi by dou y, right? So we can say dou phi by dou y is equal to what? J coefficient is y square minus xz, right? Y square minus xz, right? So here itself I can write d phi by dy is equal to y square minus xz. So cross multiply, then you can say integration of d phi is equal to, same method you have to apply, that is y square minus xz into dy. All right. So this is what we'll get, the d phi is equal to pi, and this is y cube by 3 minus x y z plus f2 of this is the x and z, right? X and z. Let's say it is equation 2, right? Similarly, we can go for the z, that dou phi by dou z is equal to, that k coefficient is z square minus xy, right? So here itself you can write d phi by dz is equal to z square minus xy, or further you can simplify this, that is integration of d phi is equal to integration of z square minus xy into dz, right? So it's on simplification we'll get that phi is equal to z cube by 3, right, minus x y z plus f3, and this is the function of x and y, right? So now let's say this is equation 3, right? So from equation 1, 2 and 3 you can add the 1, 2 and 3, right? So simplification, you will get the phi is equal to x cube, right, plus y cube plus z cube by 3, right, minus x, y and z. So this is your required solution. So first we prove that whether the function, the given vector f is a irrotational or not. For proving that, we need to establish the relation that we have to satisfy whether the curl of the given vector is 0. So we already calculated, we get that curl of a given vector is 0, and then we find out the scalar potential, right? So scalar potential of that given vector is this one. Thank you.